Hello everyone. Today we'll be looking at the difference between specific heat capacity and heat capacity. Um, Actually, we have some other videos in regards to this in our playlist, and I want to encourage you to actually go down there and try some calculation and learn how to do some calculations there. But today we're going to be looking at how to differentiate them. Now, one thing about them, all of them, they are related in some cases because they all talk about energy. But there are some basic differences that you should know about them. One of the things about specific heat capacity here is the amount of heat required to change the temperature of a substance by 1 K, while the specific heat capacity is the amount of heat required to change the temperature of a unit mass of a substance by 1 K. Now, the SI unit, the unit for heat capacity is joule per Kelvin, while the unit for specific heat capacity is joule per gram per Kelvin or joule per kilogram per Kelvin. The next one we should also note here is that in heat capacity, it depends on the mass and the nature of the substance. Now we'll look at it with time. We're going to go into details on this to help us understand that because we normally use it in during the calculation. While the specific heat capacity is independent of the mass but depends on the nature of the what substance. This one depends on the mass and the nature of the substance, while specific heat capacity depends only on the nature of the substance. Heat capacity is a property of a substance, while specific heat capacity is a property of a substance per unit mass. Now, if you are joining us for the first time, we want to encourage you to subscribe. If you have any question you want to ask, you can also leave it as a comment there. Then I will encourage you to just go through, make sure you watch this video to the end so that you will be able to understand more in it. So the next thing we're going to be looking at here now, we're going to try our hands with some calculation in order to understand how to apply some of these rules in our calculation. All right, the next thing, like I said, we are going to be looking at. So like we are already known, we said that specific heat capacity depends on the mass and the nature of the substance. What it simply means is that if we have this as our heat capacity, it depends on what mass and what times the nature, that is the specific heat capacity. C, I can say, okay, specific heat capacity. So what it means that heat capacity is directly proportional to mass. If this one is a constant, assuming that we have that means specific heat capacity is a constant, meaning that as the mass is increasing, the heat capacity will also increase. And also, if you want to calculate the heat capacity, it simply means mass multiplied by the specific heat capacity. But then to find the heat capacity of the specific heat capacity of a substance, we consider the quantity of energy of heat. Let's say quantity of heat, and then we know that to calculate the quantity of heat, we need the mass, we need the specific heat, which we can call C, and the change in temperature. Now, to get the specific heat capacity here, that means the C will then be quantity of heat over what mass multiplied by change in temperature. So with this now, we can calculate the specific heat capacity, while with this other one, what we have here, we can use it to multiply to get our heat capacity. Now, the next thing we're going to do now is to look at some questions. There are some series of questions I know I believe that will help us to really understand what we are talking about when we come to question issues like this. So the next one I'm going to be doing now is to look at those questions and then do justice to them. So the first question we'll be looking at here says that a metal rod with heat capacity of 585 joule per Kelvin is heated until its temperature changes from 25 to 95 degrees Celsius. Calculate the quantity of heat supplied to the rod. Then the next question there is if the specific heat capacity of the metal is 390 joule per Kelvin per kilogram per Kelvin, find the mass of the rod. Now, you notice that we have two questions here to take care of. The first one is the quantity of heat supplied. Now, anytime you want to calculate the quantity of heat supplied, we can say we normally use this formula: mass and specific heat capacity and multiply by change in temperature. So, and for that reason, what we're going to do here is we're going to be applying this formula. We have the mass. The mass of the rod is not, it's a calculate the mass of the rod. The mass of the rod is one of the things we are going to calculate. And then where we also know that specific heat capacity of the substance, that means this one we might not give us what we want. We know that specific heat capacity is always equal to mass over heat capacity. Are we together? So if it's like that, the only thing missing in this is just the change in heat. The only value there that is missing is just the change in heat. So for that reason, that means if we are able to get the change in heat and add it, multiply with whatever we have as heat capacity, we'll be able to calculate the word quantity of heat. That is just the simplest thing here now. What we have as heat capacity to be what? 585 joule per Kelvin. And then change in heat, our change in heat is equal to 90. Change in temperature, sorry, 95. This will give us, that will give us 0. The other one will give us, I think, 70 degree. If I'm not mistaken, let me be sure of what I'm doing here. Okay, I think it's correct, but let's see, do some. It's correct. Now we have 70. So now what do we do? Like I said, a heat capacity is this, and then they have something in common. That means they are related here. So, but to get the quantity of heat, we need to multiply it by what? Temperature change. This one is just like heat capacity multiplied by what? Temperature change. Now we have the temperature change. So to get the quantity of heat will then be equal to times 70. So what do we have? 70 times 585. That will give us 75. That will give us that is the heat. So the quantity of heat supplied. That's the quantity of heat supplied to that to the rod. So this is done. You can see how we arrive at the answer, and you should also note this thing how to apply it, because initially what I was planning to do is to use it because this tends to be I'm always I'm used to this anyway. This very one I normally use in calculus, but then I noticed that this was given specific. They gave us the specific heat, but not we are looking for the mass. Because we are looking for the mass, now what do? We apply that through there. So the next one now we're doing here, you say calculate, find the mass. Now we have we know that looking at this, we know that specific heat will give us mass is equal to mass times heat capacity. Heat capacity is equal to mass times specific heat capacity. Now we have our specific heat capacity as what? Our C is what? Per kilogram per Kelvin. So what do we do next? If we substitute everything, we have this one to be what? 589 equal to 9390 multiplied by what? Mass. We can say the mass is what? Let the mass be m. So in that case, what else are we going to do? We make the mass the subject of the formula from this our value here. If we make it the subject of the formula, what it means is that this being the subject, we have, what are we looking for? Mass. Mass is what we are looking for. It will be equal to over what? C. So if it's like that, what are we going to do? We get the mass. This is the mass. We don't know. We have the specific heat capacity, which is 585 all over our 390. So this is what if we divide it through, if we divide it 585 divided by 390, we have what we have here is it will be equal to 1.5 kilogram kg. So this is one of the ways of solving the problem, and we're going to be solving another question now that might be very interesting to you, and I want to encourage you to just stay by and watch it to the end. So here we another question we're looking at, saying that a heat coil of resistance 40 ohms is connected to 240 volt supply for 6 minutes to boil a quantity of water in a vessel of heat capacity 585 joule per Kelvin if the initial temperature of the water is 25 degrees Celsius and its specific heat capacity is 4.2 times 10 raised to the power 3 joule per kilogram per Kelvin. Calculate the mass of water in the vessel. Now, what are we doing here? We say that we are going to be calculating the mass of the water in the vessel. The first thing we do here is to get the quantity of energy that this coil supply to the vessel and the water. Now, to get this thing done, we know that in electricity, to calculate energy, that is, we can say quantity of heat energy. Since we are talking about we have an electric current here now, we know that we get it by volts over R, and then we have our time. That will give us a quantity of electricity or quantity of energy we are looking for. So here, the volts, we know our vote is what? 240 volts. The R is equal to 40 volts, and then time is what? 6 minutes. That means we multiply by 60 because we talk about seconds. The unit is normally in seconds. So here now, what do? We're going to substitute all these things in what we have in the formula. We have multiply 6 times all over 40. So what are we doing here? We multiply. If we multiply through squared times 6 times 60, divide by 40, we have will be equal to this is the quantity of electricity supply, quantity of energy supply, electrical energy supply. So this is what we have. Now we talk about, remember, uh, heat supply. The heat supplied is equal to what? Heat gain. Heat gains by what? The vessel. I use V. Okay. Vessel plus what? Water. Plus water. So what next? We have the quantity of heat already. Perhaps I'm going to make some press some space here. Let's leave this thing here in case we'll come back to it. So now we're going to get the heat gained by the vessel and the water. Heat gained by what? Vessel plus water. So for the vessel, we have the specific heat capacity of the vessel. We can say that the vessel now, since we have the specific heat capacity, I think that's what we have here. The heat capacity of the vessel, we can say plus, we can say that we can call the mass we are looking for, the mass of water, we can say it's x. X is the mass of the water we are looking for, and times specific heat capacity of the water, which is given to us as this 4.2 times 10 raised to the power 3 multiplied by change in temperature. That is temperature. Initial temperature we have there is 25. Initial temperature is 25. That's the final temperature now boil. That is boiling. But water boils at what? 100 degrees Celsius. That would be 100 degree minus 25. So what do we have there? We're going to have 100 subtract by 25. We have 75. So what we have here will be 242 times 10 raised to the power 3 x bracket 75. If we multiply through, then what we have here, we have times 75. This will be that is heat gained by the vessel, that of the water times 75. We have heat gained by the water will be x. So that's what we have. Now we'll go back to what we have. Quantity of heat supplied. The total heat supplied to the vessel and water is 518,400 joule equal to 43575 plus 315,000x. So when we subtract this, collecting like terms, we will have x equal to 518,400 subtract from 43875. So when we subtract this, what we will have will be, let's look at what we get here. 51 subtract from 43875. We have equal to No, 47525. Then now to find the value of x, we mean 474,525 divided by 31500. What we get here will be divided by 315,000. Then we have what we have will be our final answer. The mass of water in question will then be kilogram. That is what we have. And thank you so much for coming this far. We're happy to have you here. And if you are joining us, we encourage you to subscribe and then make sure you leave your questions as a comment there. And then like, share, and then you can, if you want to speak with us directly, you can visit our Facebook page. It's also in this channel description. You will see our Facebook page there, and then you can also get there to us to communicate with us, because there you can also chat with us, and then even you can even call us, because there's a number there that you can access via our Facebook page. And thank you once again, and goodbye for now.